Some progress has been made using the trivial character monomial trace relationship to understand the monomial traces better. Let's look at that progress from the point of view of acyclic orientations of graphs. So recall that the incomparability graph of P is the graph whose vertices are the elements of P and whose edges are pairs of incomparable elements. So for example, let's look at W equals 2, 4, 3, 1. F of W looks like this. And the post set, so this is F of W. The post set of F of W, the post set of paths in the path family of type E, looks like 1 is incomparable to 2 but less than 3 and 4. 2 is incomparable to 3 and 4. 2 is incomparable to everything because it touches 3 and 4 here and it touches 1 there. So the incomparability graph of P of FW is 1 is incomparable to 2, 2 is incomparable to 3 and 4, which are incomparable to each other. So we have these edges. Now an acyclic orientation of a graph is an assignment of directions to every edge. So that there's no cycles. So for example, you could orient the edge between 3 and 4 toward 4, the edge between 2 and 4 toward 4, and then have an edge from 3 to 2 and 1 to 2. And then another orientation is we can have the edge from 2 to 1 go to 1, from 2 to 3, 4 to 3, and 2 to 4. So these are two possible acyclic orientations of that graph. We just have to make sure that there's no directed cycle here. We define a source of an acyclic orientation to be a vertex with n degree 0. And an inversion to be an edge that points toward the smaller number. So if we look for sources here, we've got 3 is a source and 1 is a source. And over here, looks like 2 is the only source. And if we count inversions, 3 going to 2 is an edge going toward the smaller number. I think that's the only one. So 1 inversion here, and then 2 going to 1 is one inversion, 4 going to 3 is another one. This goes to larger, larger. So this has got 2 inversions. The theorem of Stanley and Shereshian and Wax is that if we look at the sign character applied to the Hecke algebra element CW, that equals a sum over acyclic orientations of the incomparability graph of P of FW, Q to the number of inversions in that acyclic orientation. And then there's a slight strengthening of this result. So this is the sum of all monomial traces. And we can strengthen this by summing over only some of the monomial traces. So here's one result. And then another result is if we sum over all partitions of n where the number of parts of the partition equals k, and that equals the sum over all acyclic orientations having k sources, q to the number of inversions in the acyclic orientation. So let's compute these sums for acyclic orientations of this graph that we started looking at. Well, there's 12 acyclic orientations. Let's see if I can fit them all here. Now it's easy to see that there's 12 because this edge can go either way. So 2 times the number of acyclic orientations of this graph. Now there's 3 edges, so 8 ways we can orient the edge toward the larger number or toward the smaller number. But 2 of those orientations are going to be a cycle this way and a cycle that way. So 6 minus 2 is, so 8 minus 2 is 6, times 2 is 12. Okay, so there is the graph written 12 times. Now we just have to orient it. So let's orient the edge from 1 to 2 upward 6 times, and then downward 6 times. And then everything we do at the other edge, we can do it once for 1 going to 2, and again for 2 going to 1. So I guess we can orient everything going up. 2 to 3, 2 to 4, 3 to 4. So 2 to 3, 2 to 4, 3 to 4. And then we can pick one edge to go down. Let's say 3 to 2. And everything else oriented up. So that's still acyclic. 3 to 2, everything else going up. And then we can try, if we do 4 to 2 and everything else going up, that's going to be a cycle. So we can do 4 to 3 and everything else going up. So 4 to 3 and everything else going up. So then we can have two edges going down. So if we have 3 to 2 and 4 to 2, and 3 going up to 4, that's acyclic. So 3 to 4, 3 to 2, 4 to 2. And if we have let's see, that's just 3 40 going up. If we have just 2 4 going up and the other 2 going down, that's acyclic. So let's have just 2 to 3 going up and everything else going down. So 4 to 3 and then everything else. 4 to 3, 4 to 2, and then 2 to 3 going up. And then we can have everything oriented down to the lower number. 3 to 2, 4 to 3, 4 to 2. 3 to 2, 4 to 3, 4 to 2. Alright, so let me circle sources. So here we've got 1 is a source if the edge comes out of it, and not in the other cases. And then let's see what else has in degree 0. Here's 1. Here's 1. Here's 1. Two is here. 3 is here. 2 is here. 3 is there. 4 is there. And 4 is there. Alright, now let's compute inversions. So how many edges going down? These all go up. So it's q to the 0th. This goes down 3 to 2. Q to the 1st. 4 to 3 goes down. Q to the 1st. 4 to 2 and 3 to 2. Q squared. 4 to 2, 4 to 3. Q squared. 4 to 2, 4 to 3, 3 to 2. Q cubed. Now we've got 2 going to 1, and we have the same 6 graphs. So I guess we just multiply all these by q. So q, q squared, q squared, q cubed, q cubed, q to the 4th. Alright, so we know that if we sum up all the monomial trace evaluations, we get this sum of q's. So in the example, this is 1 plus how many q's? 1, 2, 3, and how many q squareds? 1, 2, 3, 4. And how many q cubeds? 1, 2, 3. And how many q to the 4th? Just 1. And then if we refine our count by looking at just orientations with one source or two sources, then now for the only partition having exactly one part is 4. So we should be able to pick out phi 4 here by looking at the powers that go along with just one source. So phi 4 of C equals 1, how many Q's? 1, 2, so 2 Q's. We had 3 Q's total, but this one has 2 sources, so I'm not counting that. 2Q, how many Q squareds? That one has 2 sources. That one has 2 sources. So 1, 2. 2Q squared. And how many Q cubeds? 1, 2, 3, but I don't want to count that because it has 2 sources, so just 2. 2Q cubed, and then Q to the 4th has 1 source. So then we could do the sum of phi 3, 1 and phi 2, 2. So that would be summing all the powers of Q for acyclic orientations that have 2 sources. So we have Q plus Q squared plus Q squared plus Q cubed. So Q plus 2Q squared plus Q cubed. So this doesn't give us a formula for phi lambda evaluations, but it gives us a formula for a relatively small sum of them, at least in comparison to this sum, which is the sum over all of the phis. This is a sum over all, just sum of the phis with a partition that has exactly k parts. So here we've got these two. So then the next question a researcher would have to ask is, so we know all the one source orientations are going to contribute to phi 4. But for the 2 source orientations, which ones correspond to phi 3, 1 and which ones correspond to phi 2, 2? At the moment, that is not known. The end.